This is Loopndroll. It is a small macOS app built around Codex hooks, and the pitch is brutally simple. Do not let Codex stop early when the task is obviously not done. The source clip that launched it is only a few seconds long, but it lands the whole idea fast. Codex works on a task, Loopndroll shows the run state, then a Telegram notification appears when the agent reaches a stop point. Under the hood, this is not a cloud dashboard selling magic autonomy. The official repo and site both say the same thing. Loopndroll is free, open source, and runs locally on your machine. So this video is not a fake cinematic trailer. It is a source-grounded breakdown of what the product really does, how the loop modes work, and why this tiny utility solves a very real Codex pain point. The problem Loopndroll is attacking is painfully familiar if you have used agentic coding tools for real work. The model says it is done, but the repo is not actually green. Tests still fail. Lint still fails. Type check still fails. Or the agent reaches a soft stopping point and needs another nudge, even though the next step is obvious. In the official README, the author spells that frustration out directly. If you have ever had to send dozens of follow-up messages just to keep Codex running, or watched it skip tests, lint, or type check even though you asked for them in your agent instructions, this tool is meant to take that repetitive babysitting off your plate. The opening source clip backs that up visually. You can see a Codex task summary, a steering prompt telling it to keep working until it is actually done, and then the Loopndroll home view where those policies become explicit modes instead of ad hoc follow-up messages. The clearest part of the product is the mode system. The official demo and the source code line up cleanly here. On the main screen, Loopndroll exposes 4 families of behavior. Infinite mode keeps pushing the same Codex chat forward until you stop it. Await reply mode pauses at a decision point and waits for your Telegram reply before sending the next instruction back into that exact chat. Completion checks mode runs a named group of commands like tests, lint, or type check before the task is allowed to finish. And max turns gives you a bounded version of persistence, where you allow 1, 2, or 3 extra turns instead of an endless loop. This is important because the product is not pretending every task needs the same control style. Some tasks need brute force persistence. Some need a human checkpoint. Some need a measurable done condition. And some only need a little more room than Codex normally gives itself. In the source clip, those modes are not buried in settings. They're the product. The deeper technical story lives in the hook flow. The repository exposes exact status strings for the lifecycle, and the demo shows those same states on screen. First, session start registers the Codex chat. Then user prompt submit captures the prompt. Later, when Codex reaches a stop event, Loopndroll decides whether Codex should continue. That is the core interception point. In the official run trace clip, you can literally see the sequence as the task executes. A prompt is submitted, a response starts forming, and then the stop hook blocks the final exit while Loopndroll evaluates the next action. The hook management code also shows which events get installed into the user's Codex configuration. Session start, stop, and user prompt submit are all wired to a managed local hook command. So the product is not faking orchestration with a visual wrapper. The orchestration is grounded in actual hook registration and local state, and the UI is basically a control surface for policies that live alongside Codex itself. Completion checks are probably the most useful mode for real repo work because they replace hand-wavy done with an explicit gate. The README says Loopndroll can require specific commands at the end of a task and keep going until they pass. The settings copy in the app says those command groups are reusable and that completion checks mode can run them before a chat is allowed to finish. That is a strong design choice. Instead of baking one hard-coded test command into the app, the product lets you define named check bundles and attach them where they matter. So if one repo needs pnpm test and pnpm lint, and another needs cargo test and cargo fmt, the model does not have to guess what done means. The app already knows. For anyone who has watched an agent declare victory while the terminal is still red, this is the part of Loopndroll that turns vibe-based completion into something much closer to a real delivery rule. The Telegram side is where the demo gets fun. The official clip ends with a phone notification from Loopndroll bot, and the README explains the control flow behind that moment in plain English. You connect your own Telegram bot token. You message the bot or add it to a group. The chat then appears in the app. From there, Loopndroll can send progress updates into Telegram, list registered chats, show status, accept direct replies, and even let you switch modes from the message thread. That matters because this is not just a passive notification pipe. In await reply mode, Telegram becomes the remote input channel that feeds the next instruction back into the active Codex chat. So the product is really doing two jobs. It keeps the local hook state in sync, and it gives you a remote cockpit for long-running work when you are away from your machine. That weekend use case claim in the original post is actually supported by the product design. The most important trust signal in this whole project is the local-first model. The README says Loopndroll runs fully locally on your machine and does not send your chats, prompts, or app data to any Loopndroll server. The repo notes tell us where the app stores its own database and logs, and the hook core code shows the exact local files it touches in the Codex setup. Those paths include the app database under application support, optional hook debug logs, and the Codex files at .codex/hooks.json and config.toml. The settings UI also exposes hook registration directly, with controls to register, clear hooks, and open hooks.json. That matters because the product is making a very specific promise. This is not a hosted agent manager where your repo workflow disappears into somebody else's backend. It is a local utility that edits your local Codex hook configuration, stores local app state, and uses your own Telegram bot or Slack webhook if you choose to connect notifications. So the honest verdict is this. Loopndroll is not a giant agent platform. It is a focused control layer for one very concrete failure mode in Codex workflows: stopping too early, stopping too often, or stopping without a meaningful completion rule. The public evidence is consistent across the X posts, the official site, the README, the settings copy, and the hook management code. You get persistent loop modes, reusable completion gates, Telegram reply routing, and a local-first setup built on Codex hooks. If you never use Codex, this app is irrelevant. But if Codex is already in your daily stack and you are tired of typing keep going, rerun tests, or wait for my reply from scratch every time, this is exactly the kind of sharp little tool that can earn a permanent place in the workflow. And because the project is open source and already shipping macOS releases, you can inspect the implementation instead of taking the promise on faith.